Jai Hind to all of you. Myself Neha, and this topic is the clamper. This has been taken from the subject Fundamentals of Electronics Engineering, and this is the second lecture for this topic. So basically, a clamper is a circuit that adds a DC level to an AC signal. Like our AC signal is in this way. So clamper will shift the DC level of this AC signal. Like it has been shifted to nearly 10 volt. So this is the DC level that has been shifted to 10 volt. So basically, clamper provides a shift in the AC signal. Clamper circuits consist of the energy storage elements like capacitor, and it also consists of a diode and a resistor, and it may be a series clamper or it may be a parallel clamper. Like this is the sine wave, and if it is passed through the positive clamper, so we can see there is a shift in the DC level of this cycle, and this shift is a positive shift. Previously this was at this level, now it has been transferred to this level. So there is a positive shift in the AC signal, DC shift, and here this is a negative clamper. So here we can see it is at the 0 DC level, and if we pass through the negative clamper, there will be a DC shift of negative. This is the shift of minus V volt, and the swing of the signals remains same. Like here, total swing is 2 volt, and in the input side there was a swing of 2 volt also. So before the clamper and after the clamper, the total swing of the signals remains same. So this is how the analysis is done with the help of clamper. Clamper basically consists of the capacitor and the diode and resistor. Here this Vi is the AC signal which we want to provide the DC shift, and this capacitor is there. So in the analysis, what we do, we first see when our this diode will be in forward bias condition. So we can see here, this is the P type and this is the N type. So this P type will be in forward bias when there will be a positive cycle here. So if this is our input, sine wave is there, so positive cycle will be here and negative cycle will be here. So in positive cycle, this diode will be forward biased, and in this positive cycle, the capacitor will be charging. So this circuit will be in this way. Like we can see, this is our capacitor and the diode has been shorted. So this is our resistor and this is Vi. So here it is positive, here it is negative. So this capacitor will be charging up to positive potential. Means this plate of the capacitor will be positive because it is directly connected with this positive polarity. So this plate will be positive and this plate will be negative, and the diode will be short. So here, so in this case, output voltage would be, we can see output voltage is here, and this is across this part, and this part has been shorted. So the output voltage in this case will be 0, and VC voltage would be equal to Vi minus VC is equal to 0. We can see VC is equal to Vi, and Vi is our if we have provided this type of waveform, square waveform, so this Vi and the value of Vi is capital V. So here Vc would be equal to V. So this is the case when the diode is operated in the positive half cycle, and in negative half cycle means this cycle, this part will become negative and this part will become positive, and the polarity of the capacitor will remain unchanged because the value of this resistance is always taken very high. So the discharge time of the capacitor will be very high. So during the condition when this side will be negative and this in negative half cycle, your diode will be in open circuit. So no current will be passing through this diode, and in that condition, capacitance will not be discharged through this resistance because due to the high resistance of this resistance, and this resistance is almost 5. It provides the 5 times of time constant. That's why discharging time constant is very high, because this value of resistance is very high. So discharging time constant is very high. So capacitor will not discharge through this resistance in the negative half cycle. So it will hold all the charge that was developed during the positive half cycle. So in negative half cycle, the same charge will be there. So it will be charged up to the potential V. So in this case, output voltage in negative uh, in uh, in negative half cycle, output voltage would be equal to minus V. Sorry, we can take also V plus V and plus V naught is equal to 0. So V naught would be equal to minus 2V. So V naught would be equal to minus 2V. So here if we draw the diagram, we will find this was our input, and for our output we have seen for positive half cycle we were getting this V naught is equal to 0 for positive half cycle. So here there will be 0 output in positive half cycle, and in negative half cycle we are getting minus 2V. This is minus 2V. So this is our output and this is our input. So in positive half we are getting the minus 2V. So we can see the DC level has been shifted to minus V, and total swing is there of 2 volt, and here also total swing was of 2 volt. So in case of clamper, only DC level will shift, the waveform of the waveform will not change, and also the total swing will also remain same. Here we can see this is the case when negative half cycle was there and their diode is open, and the capacitor will hold all the charge that it was charged up to in the positive half cycle. So in that case, output voltage would be minus 2V, and in positive half cycle output was 0 and negative half cycle output was minus 2V. So this is another circuit that we can see. Here also we have taken the input signal as a square wave. In positive half cycle it is of value V, and in negative half cycle it is of value minus V. So we will see the case when this diode will be in forward biased condition. So it will be forward biased when this will be positive and this will be negative. So in positive half cycle, the diode will be shorted and resistor, and this is our V naught. So here this is plus minus. So capacitor will charge up to this potential. So in this case output would be 0, and we can see the VC would be equal to V minus VC is equal to 0. So VC would be equal to V in this case. And in negative half cycle, this circuit will become like in this way. The diode will be open circuit and resistor is there. So V, and this will be minus and this will be positive now, and the capacitor will hold the charge that it has been charged in the positive half cycle. So in this case the output voltage would be equal to, output voltage is across this point, so output voltage would be equal to V plus VC plus V naught is equal to 0, that is V plus V is equal to minus V naught, or we can say V naught is equal to minus 2V. So this would be like in this way. This is our input waveform, plus V minus V. So output waveform would be in this way. Like for positive half it will be 0, and for negative half it will be minus 2V. So we can see total swing is here 2V. And here also in input case total swing was of 2 volts, and in output signal also total swing is of 2 volts. So and here the DC level has been shifted to the minus V volt. So this is the negative clamping, because DC level has been shifted to the negative side. So this is another circuit in which we have taken the square wave. In positive half cycle, it has an input of 10 volt, and in negative half cycle, it has an input of minus 20 volt. And this is the circuit for the clamper. This is the biased clamper because we have used the 5 volt supply here. So we can change the amount of the DC level through this 5 volt supply also. And here this is an ideal diode because there is no, we have not mentioned it as silicon or germanium. So this is the case of the ideal diode. And now we will see in first condition, we will see that in which condition our diode will be in forward bias condition. So we can see N side is this and P side is this. So this diode will be in forward bias condition when this signal will be minus here and plus here. And in minus sign, we can see the voltage is 20 volt. So this would be 20 volt here because this diode will be forward bias only in this condition. So in this condition, our capacitor will charge with polarity like in this way because here negative polarity is there. So this plate of the capacitor will be negatively charged. So this supply would be like in this way, and output voltage. Now this diode will be short circuit. So this circuit will become like in this way, like okay. So now the output voltage, we can see this diode has been short now, and now this supply 5 volt is in parallel with this output voltage. So output voltage in this case would be equal to 5 volt. And now we can find the value of Vc by applying KVL through this part. So output voltage would be equal to minus 20 plus Vc minus 5 is equal to 0. So Vc would be equal to 25 volt. So our capacitor has been charged up to the voltage 25 volt, and this is the case when negative cycle is there. So in negative cycle, output voltage is 5 volt and Vc is 25 volt. Okay, so Vc was 25 volt and output voltage was 5 volt in negative half. Now, when there is a positive half cycle, the circuit will become like in this way. We can see that this diode is now open. Diode has been open now, and this is the 10 volt supply with positive polarity here, negative polarity here, and capacitor has been charged up to 25 volt here with minus polarity here, plus polarity here. So we can now find the output voltage in this case. So output voltage will be 10 volt. By applying KVL through this loop, we can find. So 10 volt plus 25 volt minus V naught is equal to 0. So it would be V naught would be equal to 35 volt. So this is the case when there will be a positive half cycle. So now we have the output as 5 volt in negative half cycle and 35 volt in positive half cycle. So we can draw the waveform like this was our input. This was 10 volt and this was 20 volt. So this was 10 volt and this was 20 volt, minus 20 volt. This was the output. So if we draw the output voltage, we will see in negative half it was 5 volt. So here this will be 5 volt here, and for positive half it was 35 volt. Sorry, in negative half it was 5 volt. So this was not the negative cycle. This was the negative input cycle. So here it would be 5 volt, and it will be 35 volt. This waveform would be like in this way. Like we can see this for another cycle also. So another cycle we can see like for negative half it has 5 volt, and for positive half it has like positive half it has 35 volt, and for negative half it has 5 volt. Okay, so total swing is of 30 volts. And here also we can see minus 20 and 10. So minus 20 and 10, the difference between this is 30 volts. The total swing in the input signal and the output signal is same in both cases. So clamper shifts only the DC level and there is no change in the waveform. Now the second case is we have taken here practical diode is there because SI is mentioned here, so it is a practical diode. In previous case, no SI was mentioned, so that was a ideal diode, and we have not taken the voltage drop across the diode in that case. And here we have taken the input signal as a square wave, that is 12 volt and minus 12 volt. So we will see the case when our diode will be in forward bias condition. So diode will be in forward bias condition when our this positive half cycle will be there, because this is the P side and this is the N side. So this diode will be in forward bias when there will be a positive half cycle. So equivalent circuit will be in that case like this is our capacitor and this will be replaced with 0.7 potential because this is a silicon diode, and here this is minus plus 2 volt, and here also resistance is there, so V0 plus minus, and this is for 12 volt plus minus. Okay, so this is VC, so this will become plus and this will become minus. This will become plus because this plate of the capacitor is in direct contact with this positive polarity. So when the diode will be in forward bias condition, capacitor will be in charging state. So it will be charged up to the potential VC. Now we can find the output voltage from this circuit, and this output voltage would be equal to 0.7 minus 2 volt. Okay, because you can see this is in parallel with this output voltage. So equivalent of this would be equal to this. So V0 would be equal to 0.7 minus 2 volt, and after solving this we will get 1.3 volt output voltage. And now we can find the VC voltage by applying KVL through this loop. So here it will be like 12 volt minus VC minus V0 is equal to 0. So 12 is equal to minus 1.3 is equal to VC. So VC would be equal to 7. So it would be equal to 10.7 volt VC. Okay, so here now for this was the case in positive half cycle. For negative half cycle, this is the capacitor. Now diode will be in open circuit. This will be the equivalent circuit in this case. This is the R, this is the output voltage, and here this is a negative half cycle, so it is 12 volt and minus and plus, and VC this was plus and this was minus, and here it was minus plus 2 volt. Okay, so in negative half cycle diode will be in reverse bias, so it will be in open circuit, and capacitor will hold the charge due to the high resistance, very high value of this resistance. So here we can find the output voltage. So output voltage would be equal to minus 12 volt minus VC minus V0 is equal to 0. So minus 12 volt minus VC minus 10.7 is equal to V0. So V0 would be equal to minus 22.7 volt. Okay, so we have obtained this output, so we can draw the waveform also. So like this was our input, this was 12 volt and this was 12 volt, And if we see our output, we are getting this output in negative half. In negative half, and in positive half, the output was 1.3 volt. So this was 1.3 volt here, and in negative half it is minus 22.7 volt. Okay, let me check. 12 volt. Okay. So this output voltage will be equal to minus 22.7, and it was 1.3. So if we check, sorry, this was minus 1.3. This was minus 1.3 because 0.7 minus 2, it would be minus 1.3. So minus 1.3. So here this diagram would be here minus 1.3. So now we can check the swing also. Between minus 1.3 and 22.7, there will be a swing of only 24 volt. Okay, so this will be the total swing will remain same. Now this is the case for the sine wave. We have given the sine wave input with 20 volt in the positive half cycle and 20 volt in the negative half cycle, and diode is a ideal diode we have taken here because no Si and no germanium is mentioned here. And we will see the condition whenever diode is in forward bias condition. So we can see this is the N side and this is the P side. So diode will be in forward bias condition in the negative cycle of the input signal. So in negative half cycle, this would be 20 volt minus and this would be plus. So capacitor, this plate will become minus, this will be plate become positive, and it will be VC. And diode will be short circuit. So equivalent circuit will be in this way. So it will be minus plus 20 volt VC minus plus. Okay, so minus plus this is 10 volt. Now here we can see output voltage would be equal to minus 10 volt because it is in parallel with this minus 10 volt. And now we can find the value of VC by minus 20 plus VC minus V naught is equal to 0. Okay, so minus 20 plus VC minus V naught means minus plus 10 is equal to 0. So VC would be equal to plus 10 volt. VC would be equal to plus 10 volt. And this was the case in negative half. And in positive half signal, okay, in positive half cycle, the circuit will become like this 20 volt. Here it will be positive, here it will be negative, and it will be just like the diode will be in open circuit, and this is like in this way R, and this is V naught. Okay, so minus plus, here it will be 10 volt. Okay, now this was minus plus VC. So we can find the output voltage here, 20 volt plus VC minus V naught is equal to 0. So V naught would be equal to 30 volt. And this is in plus positive half cycle. So if we draw the waveform, we will find like this was our input signal, 20 volt minus 20 volt. And for output signal, we will see like in positive half, the output was 30 volt. So that was 30 volt and input was minus 10 volt. Just like this, minus 10 volt. Okay, minus 10 volt. So this was your output waveform and this was your input waveform. So this is how we can solve the clamper circuits with the input sine wave. Now this is another question, and here also we have taken the diode as idle diode, and the potential voltage that we have taken peak voltage is 120 volts. So here we will see the condition when the diode will be in forward bias condition. So in positive half, because this is the P and this is then positive half, this diode will be forward bias condition. So in positive half cycle, capacitor okay, so plus minus 20 volt. So here we will see the output voltage is V0 is equal to 20 volt because this is directly in parallel with the resistance. So V0 would be 20 volt. And now we can find the value of Vc. So Vc would be equal to 120 minus Vc minus V0 is equal to 0. So 120 minus Vc minus 20 is equal to 0. So Vc would be equal to 100 volt. So here Vc is equal to 100 volt. Now in negative half cycle, so this capacitor and diode will be in open circuit now. Now this resistance will be there. Now capacitor like plus minus Vc. And this was minus, this was plus 120 volt is there. Now in this case, output voltage can be find out this minus 120. After that minus Vc minus V0 is equal to 0. So V0 would be equal to minus 120. Vc value was minus 100. So it will be minus 220 volt V0. So it is in negative half cycle. So output will be like in this way. This is 120 volt and this is 124. This was input. And for an output side, we can see for negative half cycle minus 1 to 220 volt is there. And for this, and here also we can see the value of Vc was Vc is 100 volt. And it is like it will be like here because capacitor is coming from plus to minus, so it will be negative side 100 volt, and in positive half cycle the output is 20 volt. So it was like 20 volt is here, and in here it is coming at minus 220 volt, and here it is 20 volt. So total swing in between it is 240. Okay, so for drawing the waveform, we can see the Vc value. Vc shows the amount of the DC level shifting. So 100 volt has been shifted, and see the sign of the capacitor. If it is coming from plus to minus, it means DC level will be drawn below the zero line. So it is at minus 100 volt DC level because capacitor is coming from plus to minus. If it is coming from minus to plus, then this 100 will be here at this place above the zero line. So it is minus 100, and in positive half cycle we are getting the 20 volt. In negative half cycle we are getting the minus 220 volt, and total swing in between this 240 volt is there. So and total swing always remains like in the case of the clamper. Now these are the different circuits we can analyze with the help of the capacitor. So this is the circuit we have taken the simple clamper, and this is basically our negative clamping is there, because we can see the DC level was this place at this place, and it has been shifted to this place. So this is the case for the negative clamping and simple clamping, because we have not used any supply here. So this is the simple clamper, and all these circuits are for the biased clamper, and this is for the positive clamping. This is also simple positive clamping, and these two are the biased positive clamper circuits. So these are the applications of the clamper, and they have some applications in the sonar and radar testing, and used as a voltage doubler. They are used to remove the distortion in the circuit, and used in video processing equipment like TV. Thank you.